Hello guys, welcome to Stats with Warnke. Our learning targets are listed below, so we're going to talk about the center, shape, and spread of the sampling distribution of two proportions. We're going to talk about conditions for inference about two proportions, or our populations. And then we're going to talk about the confidence interval for comparing two proportions. Before we get into that, though, I want to bring back an old idea that we had from chapter number 6, talking about discrete random variables and how we can combine two things into one. So here's a problem. We're looking at auto dealership, and they have two different models. They can either sell cars or they can lease cars. And down below each of those, we have the mean and standard deviation for those two distributions. And then it says find and interpret the mean of t, where t is defined as x plus y. Assume that x and y are independent. So if you remember from this chapter that we can combine the means by adding together the means of each individual part. So the sum of the means is the mean of the sums. So we add those together and we get 1.1 plus 0.7 gives us 1.8, and for the interpretation that means over many Fridays the dealership will have approximately 1.8 cars in the first hour of business, and that was what the context of those numbers were. What I really want to go over though is question number 2. Compare the standard deviation of t. So when we were adding together the means, we were able to take those individual values and add those together, and that gave us our answer. But if you remember, for our standard deviations, the process is a little different. So we still want to combine them, but we aren't able to just add regular standard deviations. If you think for just a second, remember what we need to do? If you said we have to add the variances, that would be correct. So we can take that standard deviation and square it, and add those two squared values together, and then take the square root of that total to get our standard deviation of those two together. So our rule is you can't just add standard deviations. You can add the variance, but you can't add the standard deviations. That's going to be really important as we talk about two proportions, because when we're adding together two sample proportions, it follows a very similar method when we're talking about the standard deviations. So let's get into that. You should have in your packet a few terms at the top and just kind of a little bit of context. So I want to get into that. If we're comparing two population characteristics and we're looking at the proportions, we have a few different notations. So we usually enumerate them, population 1 and population 2, but we can also use letters to indicate which population that we're talking about. So for population number 1, we have our population parameter, our proportion. And for population number 2, we have our proportion for that as well. From each of those, we can take a statistic. So we have p hat sub 1 and p hat sub 2, and our sample size, n sub 1 and n sub 2. Those are just some terms or some variables that you're going to see popping up from time to time, so you want to get familiar with that type of notation. So let's get into the sampling distribution. When we take a look at a sampling distribution, well, if you remember from what we've been doing in the last couple chapters, we would like to look at the center, shape, and spread, and we have some conditions that go along with those. So the first one is for our shape. Just like when we had one proportion, if we want to know the shape of it, we can take n times p and n times 1 minus p, and if those are greater than 10, that would make it approximately normal. That same context applies when we're talking about two proportions. We just take n times p for each of those individual proportions, and as long as all 4 of those are at least 10, we'll get a shape that's approximately normal. As per usual, the simple random sample from each of those populations is one of our prerequisites. And then the mean can be the difference between those two. So similar to our discrete random variables, where the sum of the means, we could add those together. The difference of the means for the discrete random variables, we can subtract one from the other. Same thing applies here. We can take our two proportions and subtract. For our spread, for our standard deviations, we combine those two individual proportion standard deviations, or the variances I should say, and then take the square root of that. So that's what our formula looks like, as long as that 10% condition is met, as long as our sample is less than 10% of our population. So here's kind of a visual representation of that. We have our sampling distribution of all the differences between our sample proportions, and then that standard deviation is the variances added together and then squared. Even though we are subtracting, finding the difference between our two proportions, that's still addition, because those two different distributions are going to have their own variation, and so we want to account for both of those. Our mean, though, is going to be the difference between those two. So let's take a look at that first example in your packet. It says Nathan and Kyle both work for the DMV if they live in different states. Nathan's state, 80% of registered cars are made in American manufacturers, and Kyle's state, only 60% of the registered cars are made by American manufacturers. Nathan selects a simple random sample of 100 cars in his state, and Kyle selects a random sample of 70 cars in his state. Let P sub n, that's obviously the proportion of Nathan, minus P sub k, that's the proportion of Kyle, be the difference in the sample proportions of cars made by American manufacturers. What is the shape of the sampling distribution of P hat sub n and P k hat sub k? So numerically, we can find the shape of the sampling distribution by looking at all of those sample proportions times the sample size, P times n. So we have the 80% times 100 and 1 minus that times 100 as well. We have 60% and 1 minus that times 70 for each of those. All four of those values are greater than 10. So we can say that the sampling distribution of P hat sub n and P hat sub k is approximately normal. So hopefully what we've done so far all kind of follows from what you remember from our last few chapters. We're still looking at proportions. We're still looking at the shape of those overall. And we're just taking two samples and putting those together and getting at still 10% of that normal condition. Find the mean of the sampling distribution. So if we want to find the mean of the sampling distribution, we're going to take each of those individual means and subtract them. The order is going to matter here, so we've kind of defined n first. So we're going to do, for our sample mean, we're going to do the sample proportion of Nathan minus the sample proportion of Kyle. 0.8 minus 0.6 gives us that mean value of 0.2. And part C, find the standard deviation of the sampling distribution. So if we want to find that standard deviation, we're going to need to use the variance of each of those values, add those together, and then take the square root. So if I slide this kind of over from the side here, right here we have Nathan's sample proportion. So we have that 0.8 and 1 minus 0.8 over sample size 100. And then we have our 0.6 and 1 minus 0.6 over 70. So those are our individual variances for Nathan and Kyle. And then we take the square root of that. Because the 10% condition is met, 10 times 100, 1,000 cars in Nathan's state. Any state that's of significant size is going to have more than 1,000 cars and more than 700 cars in Kyle's state. This is appropriate, and our standard deviation that we end up with is 0.0709. Once we have that kind of established, just kind of the basics of here are some different things we can do, we do have some conditions. You're going to find those in your packet. What we're going to use those conditions for is for our confidence intervals. Once we have those two differences in our sample proportions, two differences in our populations, we like to compare them and see what is that true difference between them. So when the conditions are met, an approximate C% confidence interval for a difference in our sample proportions is displayed right here. So we have the difference in our proportion means plus or minus our Z star value. So that Z star is going to be the critical value of a standard normal curve And that's just like what we calculated in the last few chapters. Anytime we're talking about proportions, we're going to be talking about z-scores. And that z-star value can be found at the very bottom of our t-table. So as we go to the bottom of the t-table, we have those infinite degrees of freedom, and right below that you can see the confidence intervals. Times our standard deviation of the statistic. So because we're looking at two proportions, we have the variance of our sample 1, our variance of sample 2. We add those together and take the square root of all of that. In your packet, you have the conditions. Those conditions should look pretty standard. Those are what we've been doing for the last couple chapters. And right below that, you'll see this problem. Many news organizations conduct polls asking adults in the United States if they approve of the job a president is doing. In 2012 and 2013, Obama's approval ratings in October were calculated, and according to a Gallup poll of 1,500 randomly selected U.S. adults on October 2nd through 4th in 2012, 52% approved of Obama's job performance. In a Gallup poll of 1,500 randomly selected adults on October 5th through 7th of 2013, that showed only 46% approved of Obama's job performance. Calculate the standard error of the sampling distribution of the difference in the sample proportions 2013 minus 2012 and interpret this value. So one of the things that will come in importance later is that they did 2013 minus 2012. But since we're looking at standard error, that's going to be using our sample proportions, calculate the standard deviation. So when we calculate the standard deviation for those two sample proportions, we need the variance. So it's going to be those two proportions are 0.46 and 1 minus 0.46 over the sample size, 0.52, and 1 minus 0.52 over that sample size. We add those together and then take the square root to find our standard error of 0.0182. Use the results from these polls to construct and interpret a 90% confidence interval for the change in Obama's approval rating among all U.S. adults from October 2012 to October 2013. So what we're going to construct here is a confidence interval. We're going to be using some notation. So one of the first things we'll need to do is establish what that notation means. So we're going to state those proportions. We have two proportions, the proportion of sub 13, proportion sub 12, where proportion sub 13 is the true proportion of all U.S. adults who approved of President Obama's job performance in October 2013. And that P sub 12 is the true proportion of all U.S. adults who approved of President Obama's job performance in October 2012. Using those two notations, we can then get into our conditions. So what we're going to be constructing is a two-sample Z interval. We're going to be using our calculators to do this. This is going to be one of the first times that we're going to kind of walk through the calculator notation, so make sure to get that out. We're also going to be writing down a little different name in our calculator, but this is technically called a two-sample Z interval, but you can also call it a two-proportion Z interval. So our first condition is that it was random. The data came from independent random samples. So both samples were stated as being random. The 10% conditions are met because more than 1,500 times 10 gives us 15,000 adults in both October 2012 and 2013. And lastly, our large counts condition is met because all of those proportions, n times p, n times 1 minus p, for both samples are greater than 10. So you can either list that all those are greater than 10, or you could write a large, like, greater than symbol, and then write 10 next to that. So we've checked all our conditions are met, so now we can move on to the next part. Do. This is kind of what you've all been waiting for. For the last few chapters, we've been writing out all of our calculations by hand. But as you've noticed on some of the AP rubrics, it says either state the test or write down the formulas. So now we're going to go the state the test route. We're going to go that route because there are so many different things that we're plugging into this formula, too many different proportions, that it's easy to make mistakes. And so if we use a calculator, that's going to make sure that we get the correct solution and include all the correct work. So once you get out your calculator, hit that stat button right next to the arrow keys. And then we're going to arrow over to tests. So if you scroll down, you'll see a lot of different options. It says 2 sample Z test, 2 sample T test, 1 proportion Z test, 2 proportion Z test. Some of these are what we've been talking about in chapter 8 and chapter 9. We've been introducing you to some of these different significance tests, constructing intervals. And so in the future, feel free to use your calculator for any of those types of problems. We'll be getting into that more in the future. If I go back here for just a second, these directions that we're going to be doing are also on page 619 of your textbook. So we're going to look for our 2 proportion Z interval, because that's what we were asked to create, was a interval with 2 proportions. So we hit enter, and you'll notice that it looks like this. That X sub 1 is the number of people who answered in this specific condition that meets number 1. So we are looking at President Obama's approval ratings from 2013. So we're going to type that in first. That was 0.46. So if you look back at the other page, it's 0.46. So I'm going to type that in. But that's looking for a number instead of a proportion. So to get that number, I'm going to multiply that by our sample size, 1,500. Hit enter, and then you see that it calculated that number for me. Our sample size is 1,500. And right there, it's looking for X sub 2. So I'm going to type that in as well. That's going to be 0.52 times 1,500. 1500. In the problem, we were asked to create a 90% confidence interval, so I need to change the C level to match that, so 0.90. And then hit calculate. It does all of that work for us, and it creates our confidence interval, and then you should go back to your paper and write that down. So all you had to do was write down 2 proportion Z interval, or 2 prop Z interval, type in our proportions, sample proportions, times our sample size, and then that gave you the interval. So in summary, that's a little bit faster than the process that we've been doing. And the calculator is something that you are completely free to use as long as you correctly name the test and then interpret what that interval means. So we are 90% confident that the true change in the proportion of U.S. adults who approve of President Obama's job performance from October 2012 to October 2013 is between negative 0.09 and negative 0.03, so between 9 and 3%. That's all I have for you guys today. Feel free to ask any questions in class tomorrow.